Hi. So today we are going to look into very important and very interesting topic, that is Maxwell Boltzmann distribution. Okay. So first let's try to understand what these graphs are giving you the information, or what this distribution is all about. So it's very simple. Okay. This Maxwell Boltzmann distribution gives you an idea of, basically, it is basically also called as a probability distribution. But more importantly, from the chemistry perspective, it is simple that it gives you the distribution of particles according to their energies. Simple. So what does it mean? That means you can clearly see that if we talk about this, whatever the energy to this, okay, there are maximum number of particles. You can clearly see because there is a peak. Okay. While if you observe, let's say very high energy, means as the energy, it is almost making it zero. Okay, almost looking like that the number of particles with a very high energy are zero, while with this intermediate, whatever this point, okay, there are maximum number. So it basically is simple that it is giving the distribution of the particles, how they are possessing the energy. What kind of energies? It can be kinetic energy or all kind of energy, total sum of the energy, but especially mainly the kinetic energy. Okay, so now why it is important? So actually, if you really want to understand in detail, and especially it would be useful from the kinetic perspective, that we have already seen that this is the energy which is corresponding to, let's say, EA, that is the activation energy. Okay, so now very important aspect, that the number of particles which are having activation, and okay, number of particles which are having the energy which is higher than activation energy, okay, is this whatever the yellow colored, yellow shaded area. Okay, so this represents basically the number of particles. Okay, let me, I can change the color so that, okay, number of particles having energy higher than EA, that is the activation. This area which I am representing, okay, yellow shade. Now why it is important? Purely simple, because we have already seen that for any reaction to proceed, we need the particles which are possessing the energy higher than the activation energy. Otherwise, they are useless. Okay. So only those particles which are possessing energy higher than or equal to EA, that is activation, they are only going to contribute to the reaction, or they are only ensuring that the reaction is basically getting maintained. So that's why we are very concerned about only those particles which are having energy greater than EA, and that this is the area. So this is getting captured very easily using this Maxwell-Boltzmann distribution. So this is the application. So you should be very clear what this area is representing, the area under this graph. So let me represent area under the curve is representing, okay, the number of particles possessing that energy. Okay, but in short, it is the number of particles. For example, in this case, yellow colored, it is representing that the number of particles which are having energy higher than activation. Okay. Now, what do you see? What else do you see? That since it starts from zero, that means there are no particles without having an energy. There are zero number of particles which this one. So at least they may be having a very small energy, but there will not be a single particle which will be without energy. That is the basic assumption. Okay. And we don't want to go into this, but this is the concept of absolute zero. Because if there is no energy possessed by the particle, okay, that means it is absolute zero, which is something which is more like a theoretical concept. Okay. Now, coming to the second part. Here we are seeing, so let's say this is having a temperature. This curve is representing temperature T1. And let's say this is T2, which is greater than T1. Okay. Now let's see what is happening. What is the impact? Now please remember that our activation energy is same. It doesn't depend on the temperature. Activation energy. But what is the impact now? That if we observe carefully that earlier without the T1 temperature, this was the area. Okay. And now by introducing or increasing the temperature, we are getting this additional number of particles, which I'm representing this with the orange color. So you can clearly see these are additional number of particles having energy greater than EA. So this yellow one is with the same temperature. So this corresponds to temperature T1, and these are the additional number of particles corresponding to temperature T2. So what is the impact? The impact of increase in the temperature is simple, that now we are having higher number of particles which are having energy greater than EA, activation. So what is going to be the impact? Simple. The rate of reaction is going to be increased as you increase the temperature. Simple. As we increase the temperature, okay, of the reactants, the reaction is going to be speeded. Okay, just by looking at this, it is crystal clear. So simple concept. Activation energy doesn't change, but the number of particles having energy more than activation energy are increasing. That's all. Okay. This is the simple concept which you can easily see from the graph. So this is the one of the best explanation to understand the impact of temperature on any reaction, on the speed of the reaction. And that's why the Maxwell-Boltzmann distribution is very, very important. Okay, from the understanding, and some direct questions are asked from this topic. So hope this is quite clear.